Hello students, welcome to the fourth and the last part of our chapter Matter in Our Surroundings. In our previous session, we have learned about interconversion of states of matter. In this session also, we are going to continue the same topic. So let's see what we are going to study in this session. So in this session, we are going to study the effect of change of pressure on the interconversion of state, then the concept of evaporation, under which we will see what are the factors affecting evaporation, how evaporation causes cooling, and the difference between evaporation and boiling. Finally, it would be followed by the exercises. So children, in our previous session we have learned how the change of temperature causes the conversion of one state of matter to another. Now today we'll see how the pressure affects the change of states. So the different states of matter are due to the difference in the distances between the particles. Like in solid, the interparticle space is very less, whereas there is a small space between the liquid particles, whereas the gaseous particles have more distance between their particles. So, when pressure is applied on gas, the particles come closer to each other, and the force of attraction thus comes into play, and the molecules are attracted toward each other, and hence the gaseous state changes to liquid state. So you can see here, if I put a gas in a cylinder, and then these are the gaseous particles which are far apart from each other. Now when I apply the pressure, the piston is pushed down, so I am applying pressure on it. So these particles, the space between them reduces and they come closer, and hence the gas turns into liquid state. Now when more pressure is applied, these particles would come more closer to each other, and hence they can be solidified. So thus, if I apply more pressure to liquid state, then it would change to solid state. So this generally happens when we apply pressure on gases, but there is negligible impact of pressure on liquids and solids because they are incompressible. We have studied this when we were studying the properties of solids and liquid, that they are incompressible. So we can change a gaseous state to liquid or solid by applying pressure. So in this way, the gases can be liquefied by applying pressure and lowering the temperature of the gas. Now, there is a special gas, that is the carbon dioxide, which when stored at very high pressure and low temperature gets solidified and forms solid carbon dioxide. This solid carbon dioxide is known as dry ice. So this dry ice is very useful in freezing food items as it produces much lower temperature as compared to normal ice, and it directly gets converted into gaseous form if the pressure is reduced without coming into the liquid state. That's why if food items are stored in it, they don't get wet, or I can say the dry ice does not cause wetting like ice. Dry ice can also be used in extinguishing fire. So in this way, by applying pressure interconversion of state can occur. Children, in our previous session, we have learned that liquids can be converted into gaseous form or vapors if we heat them to the boiling point. But you must have observed that if you keep water open, then after some time that water gets evaporated and no water is left in the container. Now, how does this happen? We are not heating it to the boiling point. Then, how does this water disappear? So, for this, we will learn the concept of evaporation. So, evaporation is the process in which liquid changes to vapors at any temperature which is below its boiling point. Or another way, I can say the liquid changes to vapors on its own without external heating. So, this process is known as evaporation, where we do not heat the liquid to its boiling point. Now, how does this happen? Why the liquid changes to water vapors without heating it? So, let's see what is the cause of evaporation. So, evaporation is caused because the particles of liquid are in continuous motion and thus they possess kinetic energy. In liquids, the particles which are at the surface of liquid have higher kinetic energy and thus they can easily overcome the force of attraction between the particles and then escape out in the form of water vapors. So in this way, the particles on the surface of liquid, they get energy and then convert into water vapors without heating. So that is why evaporation takes place. So there are a few important points regarding evaporation, that evaporation takes place at a temperature below the boiling point of liquid. We need not to heat the liquid to its boiling point to convert it into gas. Evaporation is a surface phenomena. That means this phenomena occurs at the surface of liquid, not in the whole liquid. Whereas boiling is a bulk phenomena, or I can say it takes place in the whole liquid in a container. Whereas evaporation takes place only at the surface of the liquid in the container. So that's why we call it a surface phenomena. Now, some of the common examples of evaporation which we can see in our daily lives are evaporation of water from water bodies like sea, rivers, ponds, etc. Then drying of our wet clothes. The clothes, they have water in it and they dry on their own. So the water gets evaporated and we get our dry clothes. Then the evaporation of spirit or perfume when the bottle is left open. You must have observed that if you keep perfume bottle open for some time, some of the perfume will disappear from it. So this happens because of the evaporation. Now let's see what are the different factors which affect the rate of evaporation. So first factor is increase in temperature. As we increase the temperature, the rate of evaporation would increase. This happens because more number of particles get enough kinetic energy to escape into the vapor state. So as the temperature increases, more particles on the surface would get heat and thus they can change their state and change into water vapors. So few of the examples are of this effect is you must have observed that our clothes get dried fast during the summer season, or if I put the cloth in sunlight, then it would dry faster as compared to the shady area. If I am putting the cloths in shade, then they would dry slowly, whereas in sunlight they would dry quickly. Then the next example is the water bodies dry up quickly during the summers. Another example of an increase in temperature changing the rate of evaporation is that during summers the rate of transpiration in plants is high, and that's why the leaves of plant shrink to prevent this water loss. So you must have seen during the summers the leaves get shrinked. This is to prevent the excess water loss due to increase in temperature. Now next, if a factor is increase in surface area. So we have seen that evaporation is a surface phenomena. That means the water particles or the liquid particles which are at the surface, they get evaporated. So as the surface area increases, the rate of evaporation also increase because more number of particles would be present on the surface. So as we increase the surface area, rate of evaporation increases. So let's see few example of this factor. Like when we dry the clothes, we generally spread them out. We don't just put the cloth as it is. So the cloths are spread out so that they can dry faster. Another example is hot milk or tea becomes cool faster in a saucer as compared to cup because the saucer provide more surface area to the milk than in cup. So you must have observed this. If you put the milk or tea in saucer, then it would cool faster and it would be easy to drink milk or tea in a saucer than in a cup. Now the next factor is decrease in humidity. Now what is humidity? Humidity is the amount of water vapor present in the air. That means if there are more number of water vapors in air, then the humidity is more. But at a certain time, the air cannot hold more than a fixed amount of water vapors, and hence the rate of evaporation decreases with increase in humidity because the air is already having water vapors, so the evaporation does not take place as the air cannot hold more water vapors. As a result, the rate of evaporation will decrease in humid weather. Now let's see few examples for this. So children, you must have observed that your clothes does not dry up quickly during the rainy season. The reason being, during the rainy season, the humidity of air is high. That's why the rate of evaporation decreases and our clothes do not dry quickly. Now the next example is that we feel more heat in coastal areas because our sweat does not dry easily due to high humidity in these areas. Because the coastal areas are near to sea, so the humidity of air is high, and as a result the rate of evaporation decreases, and hence our sweat does not dry easily and we feel hot in the coastal areas even though the temperature of these areas is less. Now next factor is increase in wind speed. So the rate of evaporation increases with wind speed as more water vapor particles move away with the wind, reducing the amount of water vapor in the surrounding. So what happens when the wind blows? The water vapor particles are also carried away with the wind. As a result, the amount of water vapor in the surrounding reduces and it allows more evaporation, and hence the rate of evaporation would increase. So let's see some practical examples of this factor. The first being during rainy season, the clothes can be dried fast under the fan. So just now we have seen in rainy season the clothes do not dry up. So what we do? We put them under the fan and as a result they dry quickly or easily. Next example is our skin becomes dry on a breezy day because the moisture present in our skin gets evaporated due to wind and hence our skin feels dry. Now let's see the next factor, that is the nature of liquid. So different liquids have different boiling points. So the liquids which have low boiling point evaporates faster than the liquids having high boiling point. For example, spirit or perfume evaporate faster than water when we put it on our palm. Say if I put spirit and water on my palm, then the spirit would evaporate faster whereas the water will not evaporate. The reason being the boiling point of spirit is very less than that of the water and hence it evaporates faster. Evaporation causes cooling. Now when evaporation takes place, it causes cooling in the surrounding. Now why does this happen? Let's see. Because during evaporation process, the particles of liquid takes energy from the remaining water and the surroundings. So the temperature of the remaining water and the surroundings get lowered and as a result cooling is caused by evaporation. So since the particles on surface they need some energy to escape out, so they take this energy from their surroundings or the water which is present under the surface. As a result that water gets cooled and at the same time the surroundings also gets cooled due to evaporation. Now let's see few practical examples of this cooling effect of evaporation. So during summer, people sprinkle water on the roof or ground after a hot sunny day. So what happens when water is sprinkled on the roof which has become hot during the day? This water gets evaporated and it is taking the heat from the roof. As a result, the water would evaporate and the roof will get colder. Now let's see one more example. During summers, our body gets hot and we perspire more. So this sweat evaporates by taking our body heat and we feel cool. So this is the way our body maintains the temperature because during summers it tends to get hot but because of the sweating we feel cool or our body temperature is maintained constant. Now let's see one more example. When we pour acetone or the nail paint remover on our palm, we feel cool. Now, why does this happen? Because the acetone present on our palm evaporates and it removes the heat from our palm, and as a result, we feel cool. Now, next example, the water becomes cold in the earthen pots, or I can say the matka, during the summer. Now, why does this happen? This happens because there are tiny pores on the surface of the earthen pot. So the water gets evaporated through these pores, taking away the heat from the remaining water. As a result, the water which is inside the earthen pot will become cold due to the evaporation of water particles through the pores of earthen pot. Whereas if you will put water in a metal pot, there are no pores, so the water will get heated and it won't be cold. So that's why we use these earthen pots or matkas during the summer season. Let's see few differences between evaporation and boiling. So boiling, it is a process in which a substance changes its state from liquid to gaseous at the boiling point, whereas evaporation is a process in which the substance changes its state from liquid to gaseous without boiling, or I can say without reaching its boiling point. Boiling is a fast process, whereas evaporation is slow process. During boiling, bubbles are formed in the liquid, whereas during evaporation no bubbles are formed. Boiling is a bulk phenomena, or I can say it occurs throughout the liquid, whereas evaporation is a surface phenomena and it takes place only from the exposed surface of the liquid. Boiling occurs at a definite temperature, and this temperature is the boiling point of the liquid, whereas evaporation can occur at all temperatures. For boiling, a source of energy is needed, or I can say I have to heat the liquid, whereas in evaporation, energy is supplied by the surroundings. So these are few differences between evaporation and boiling. So children, I hope now you can write the answers of the following questions which are given in this exercise. So that's all for today's session. Thank you children. Take care.